Okay, so last lesson, I wanted you all to do this is chapter 1, part 2, HCF and LCM. Okay, then we worked on we talked about HCF, we started on LCM. So these were your homework questions. Exercise number 7. Okay, so you are given these values. A is equals to 2 cubed times 3. Should we take our calculator and quickly press? This becomes 24. Should we? There's no need, okay? If you do that, you're just giving yourself more work. Okay, so now we have all these values. They are roughly arranged properly already, except for the 5 over here. So we see that the 2s are in one column, the 3s are kind of in one, and the 5 is like not really in one column. Huh? Find the LCM of A and B. So if you want, if you're still not too familiar yet, it is okay. Write them down. Just A and B. Remove all your distractions, which in this case is your value of C. So B has a value of 2 times 3 squared times 5. Therefore, the LCM of these two numbers will be, we look for the highest or lowest power? Highest. So 2 power 3. How about the power of 3? 2. Hey, I noticed that they didn't write any power here. Do you remember what this is? Power 1. Yes, power of 1. So between 1 and 2, 2 is bigger. How about the 5? Do I need to write it down? Do I need to write the 5 down? But we said we wanted the highest power, correct? What is the power of the 5 over here? This has a power 1. Yeah, you're right. This is power 1. But there isn't a 5 in my A. Can I introduce a 5 myself? Cannot. Can I just take my pencil, right? Times 5, power 0. Will it work? Will it work? Will it work? Can you take your calculator? We actually went through this before. Can you take your calculator, press 5 power 0? What do you get? It is 1, right? So if I take a number, A, which is 2 power 3 times 3, which we know it is 24, and then I multiply by 1. Does it change the value? If I multiply by 1, do I change the value? No, right? So can I put 5 power 0? Yes, because I'm just multiplying by 1. Now with this, the reason why I'm doing this is so that you can recognize, oh, there is a 5 over there. It's just that the power is how much? 0. And therefore, I put 5 power 1. Do I need to write the 1? Okay, so in summary, this is what it looks like for many people, okay? When they are doing this, teacher say, write down the highest power. 2 power 3, 3 power 2, and then when I see the 5 appear here, the other one doesn't have 5, I just copy down the number. Okay, fine. You can think of it that way. Just copy down the 5. Whether it's power 1, power 2, power 3, whatever. That is one way to look at it. But if you want deeper understanding, if you want to understand what's happening, you have to know that actually there is a 5 over here. It's just it's power 0. And then our logic doesn't change. Choose the higher power. In this case, it is a 1. Just put it down. Okay? This is now our LCM. They are asking for the LCM value. Did they say put it in index notation? No, they didn't say put in index notation. So I cannot leave my answer like this. This is called index notation. They didn't want that. So you have to evaluate, which means you take your calculator and you press 8 times 9 times 5. So 360. That is our LCM. Okay, can I have a show of hands who got this one correct? Okay, who got it correct by using your primary school method? You know, you list everything down. I hope not, because you need a lot of space. Okay, let's move on to part B, where we have our A, 2 power 3 times 3. Our B value is 2 times 3 squared times 5. And watch how I write my C. 2 power 3 times 5 squared times 11. You notice I arrange them accordingly? That is what I want to see. Can? Is it very difficult to leave a space over there? No. So follow my recommendation. Is it wrong if you If you don't leave a space, is it wrong? No, it's not wrong. It's just making things difficult for yourself. Okay, now we find the LCM. So 2 power 3. How about the 3? 3 power 2. Hey, but C doesn't have 3, no? Power 0. So what is the higher power? Still 2. So 3 power 2. And then 5 square and 11. Okay, due to a lack of space, I'll just continue on the right hand side. 8 times 9 times 25 times 11. This is a big number. 19800. Okay, so this is our LCM. Any questions? Okay, so then I ask you to do exercise number 8 as well. So the numbers A and B written as the product of their prime factors, they placed it in this format, index notation. It is a good thing. Please don't go and evaluate it. They want the largest integer, which is a factor of both A and B. The largest integer, which is a factor of both A and B. What are they asking for? Yeah, they're asking for H. It's just another way of saying it. So part A, for A, okay, you can write down A and B, but because there's a lack of space, right? I'm just going to write the HCF straight away, which you eventually should be able to do as well. Okay, just look for the common factors. 2. How many 2's are in common? How many 2's are in common? There are 2 of them, right? So I write down 2 power 2. In other words, I take the smaller power. How about 3's? Are there any 3's in common? 1 only. So I write times 3 power 1. Power 1, do I need, right? No need. So the HCF is 4 times 3, which is 12. Done. This is the answer for part A. And now the answer for part B, we're looking for the smallest integer, which is a common multiple of A and B. What are they asking for? Smallest integer, common multiple of A and B. What do they want? LCM, lowest common multiple. So the LCM for A and B, take the higher power. So 2 power 3, 3 power 4. Do I need to write the 7? Yes. Times 7. And then evaluate that. 3 power 4. 4. Yeah, 4, 5, 3, 6. Big number. So this is our LCM. And then we move on to part C. Part C is now quite a different question. The smallest positive integer n for which 2 power 3 times 3 times 7 times n is a multiple of B. Honestly, who understand the question? Anybody here understand? Quite difficult to understand, right? For most of you. In fact, when I was doing this as a student, I thought it was quite difficult to understand. But let me try and help you break it down, okay? That's what I'm here for. I'm here to teach, but I'm not here to give you the answers. What do you notice about this number here? 2 power 3 times 3 times 7. What is this number? Do you notice? Can notice? What is it? A, right? A. Come on, guys. This is just A. The highlighted part is just A. But they multiply by n, isn't it? A times n. Where n is an integer. Remember what an integer is? Up there, written down. Integer is positive and negative whole numbers including 0. Oh, now I have an integer times A. Basically a whole number times A, okay? That answer, a whole number times A, is called a multiple of A. Do you agree? For example, I'm thinking of a number. Okay, let me whisper it to you. The number I'm thinking of is 13. Okay? This number times 3. Wouldn't that be a multiple of the number I was thinking about? Because 39 is a multiple of 3, isn't it? Of 13, isn't it? I'm thinking of a number. Let's say the number is 5. 5 times any integer. Let's say 4. Answer is 20. Isn't 20 a multiple of 5? Correct? So you see, what we have over here is A highlighted times n. Okay, so this whole thing, this entire portion is known as multiple of A. Agree? Agree with me? Yeah, this is multiple of A. Okay, nothing scary about it. Now they also say that, oh, this number, which is the multiple of A, is also a real. What is this? It's also a multiple of B. Okay, so now we are looking for a number that is a multiple of A and also a multiple of B. What do we call that? Is it HCF or LCF? Multiple. We are looking for multiple. A number over here, we are talking about this number. I'm not referring to n yet. This number that I circled is a multiple of A, and it is also a multiple of B at the same time. So what do we call this kind of number? Okay, specifically we call it a common multiple, right? I cannot say it's the lowest common multiple unless I fully understand the first portion. It says the smallest positive integer. They want the smallest value of n, so that this is a multiple of A and a multiple of B. With that understanding, they are looking for LCM. Okay? If they didn't say smallest positive integer, then we are just looking for common multiples of A and B. Understand what is happening so far? Okay, so this purple circled number is called the LCM of A and B. Have we already found it in the previous part? Yes, right. Part B, LCM of A and B. It is 4536. Apparently, this is 4536. Then what is that? Divide, correct? What divided by what? 4536 divided by 2 cube, 3, and 7. Do you agree? Okay, now, before you go about, calculator 4536 divided by 2 cube, 3, and 7. Is there a faster way? Is there a faster way by comparing this 2 cube, 3 power 4, and 7? Compare this. Okay, you can talk to your friends, think about it. Is there a faster way to find n without using 4536 divided by this? By simply comparing 2 cube, 3 power 4, 7 with this. If you think there's a faster way, write it down. What is the answer for n? And then you take your calculator, 4536 divided by this, you get the same answer. If you do, you are correct. Okay, if you need help, raise hand. I will come to you. You have to clarify your doubts if you have any. Otherwise, if we keep going on, and then you're getting more and more lost, it will be more difficult. You have the answer already? So in part C, our value of n, or you can write smallest n. What is it equal to? What is the value in terms of index notation? Something to the power of something. What is it? If you are doing comparison, just comparing. What do we have? 2 cube, same, right? 2 cube, same. Just look at the green and the yellow highlighted ones. 3 power 4 and 3. What is the difference? How many 3's are missing? 3. 3 3's are missing. Those, and these two are supposed to be the same. So these 3 3's that are missing, where are they found? Inside the n. Okay, so that's what's happening. There's a 7 here, there's a 7 here. So n must be 3 power 3, which is 27. And then if you did 4536 divided by this number, you also get 27, correct? Yeah, correct. So our working can look like this. 3, 3, which is 27. Done. You can do a division if you want to, but I just need you to be familiar with this. Okay, so exercise 9 is also your homework. Find the smallest integer, which is a factor of both A and B. Part A, we are looking for HCF. Of these two numbers, we've got our 2 square, we've got our 3 square. So 6 square is 36. Part B, we want our LCM. 2 square, 3 power 3, and 5. How much? 540. Okay, thank you. 540. And now we have another one of part C. Find the smallest positive integer value of n for which 2 square, 3 square, 5 times n is a multiple of b. Okay, so same question again. Does this look familiar? What is this actually? The yellow color portion. The yellow portion is just a, isn't it? But when I circle the whole thing with the times n, this is now a multiple of a. At the same time, it is a multiple of b. Then they want the smallest positive integer value of n. What are we looking for? LCM. Okay, now. So our LCM of 2 square, 3 cube, and 5. This is the same as 2 square times 3 square times 5 times n. These two are the same thing. Now I'm just going to compare. Okay, since they are the same, let me look at the 2 square and the 2 square. Same, right? Okay, no problem. 3 cube. Oh no, how many 3's do we have here? 2 of them, right? Hey, I said that they are supposed to be equal, but on the left hand side, I've got 3 3's. On the right hand side, I only have 2 3's. Where's the third one? It is inside the n. So I can write n equals to 3 so far. And then I've got my 5 over here and the same 5. Okay, so therefore, our n is equal to 3. Done. It's just a comparison. You can do the division if you want. But I tell you a secret. Okay, let me stop recording. Exam come out, then they don't know. Okay, 2 best friends, Peter, George, working together at shop. Peter works once every 15 days. I don't know what kind of job that allows him to work once every 15 days. So 1 month, he probably works 2 days only. George works every 6 days. How many days do they have to wait until they get to work together? So think about it. Make sure you understand the question. If you do not understand the question, you cannot do it. So spend some time think. Do you understand the question? Understand? Okay. Now, what are they asking for? Are they asking for LCM or HCF? You have to decide. Okay. So in this case, they're asking for, you are right, LCM. And then how do we present our work? So 15. Same thing, 15 will be our 3 times 5. Okay, then I know the 6 will require a 2. So 3, let me give it some space. 6 will be 2 times 3. We are looking for LCM. So 2 times 3 times 5, we get 30. How many days do they have to wait until they work together? They have to wait for 30 days. They have to wait for 30 days. Yes. How many days do they have to wait until they get to work together? Bread rolls, they are sold in packs of 48. Chocolate bars in packs of 150. He buys the same number of bread rolls as chocolate bars. Take some time, make sure you understand what's happening. The bread roll, wow, 1 pack, 48 of them. Chocolate bar, 1 pack, 150 of them. Somehow he bought the same number of bread rolls and chocolate bars. Find the least number of chocolate bars that you could have bought. Is this a question on HCF or LCM? Think. HCF or LCM question? Yes, it is an LCM question. So then we have to write down our 48 in index notation. So 48 divided by 2, 24, 2, 12, 2, 6, 2, 3, 3, and 1. The other number is 150. 2, 75, 3, 25, 5, 5, 1. Okay, so our two numbers are 48, 2 to the power of 4 times 3, 150. 2 times 3 times 5 squared. This is an LCM question. So LCM, 2 power 4, 3, 5 squared. This is the number of bread rolls, which is also the number of chocolate bars that were bought. It has a value. Actually, no, we don't need to find out this value. Okay, so this is the number of chocolate bars that you bought. But they are asking for the number of packets of chocolate bars. Okay, so this is the chocolate bars bought. So number of packs equals to, what should we do to find the number of packets of chocolate bars? One packet has 150. What about this? Divide, correct. Divide what? Divided by what? Number of chocolate bars divided by the number of packets. Number of divided by 150, correct? Yeah, correct. But instead of using calculator to do your division, you can also try, just a practice, use this, you divide by 150. Meaning you find the difference, not the subtraction difference. Find the difference visually. What are the factors that are missing? Okay, so we compare 2 power 4 and 2. So what is the, yeah, the difference is 2 power 3, right? 3 and 3, same. 5 square, same. So the number of packs must be 8. If you don't believe, you go and work it out. 2 power 4 times 3 times 5 squared divided by 150. You will get 8. Okay, any questions at this point? There are no questions. Please do exercise 11 now. 11. Okay, yeah, this is not a survivor bodies again, which means that at what time do they flash? 0909. They flash at 0909. Anybody needs to explain? Or do you need more time? Who needs more time? Raise your non-writing hand. Okay, do. If you are having difficulty with this, here's the clue. LCM, which is 450, we break it down again to 225 divided by 3, 75, 3 again, 25, 5, 5, 5, and 1. And then our 15 is simply 3 times 5. So you write LCM 2, 3 square, 5 square. HCF 3 times 5. So we are like reversing. We're going to reverse. In fact, you can, I think it'll be easier for you to put it lower. Okay, then you have your, like this, okay, two numbers, A and B. We don't know what they are yet, but this is what it's going to look like. Okay. Since we learn HCF first, maybe we deal with HCF. All right. What do you remember about HCF? What do you remember about HCF when we are doing this presentation? How did we get the 3 in the HCF? Tell me. How do we get a 3 in the HCF? What must be present in A and B? A and B must have 3, right? Must they all have only 1 3, or can they have more? One of them can have more, but the other only can have one, right? Or both of them only have one tree, possible? Okay, so those are the things in our mind. What I know is that both of them minimally will have one tree. Agree? The power may change. Maybe this power can change. But the other one confirm is power 1. All right? What about the 5? Can I say the same thing? Yes. Times 5 and 5. One of them must be power 1. The other, I do not know. Maybe this is the one with a different power. Maybe this is the one with a different power. I don't know. Okay, so these are the boxes over there represent the unknowns that are in my mind. Maybe they're all ones. Life will be very easy if they're all ones, but probably not. Let's look at now the LCM. We started the HCM already, LCM. LCM says 2 times 3 square times 5 square. Why will the LCM show a 2? What? One of them has a 2. Can I have both having a 2? Can? Think, can I have both having a 2? Cannot. Why cannot? What about the HCM? HCM don't have 2. Okay, if you are looking for at the LCM by itself, then yes. If you are looking at LCM by itself, yeah, this could be a 2, this could be a 2. But if I have a 2 and a 2 here, my HCF must have a 2 also, because it's common, isn't it? So now our conclusion: can there be 2 and 2 here at the same time? Cannot. Only one of them can have 2, right? Choose one of them to have a 2. Let's say A has the 2. 2 times. Okay, so far? Now, of all the factors, 2, 3, 5, 3, and 5, I have already confirmed that the 2 is correct. You agree? The 2 over here is correct already. It cannot be power 2, because if it is power 2, my LCM must have 2 power 2. So now, because my LCM has a 2 power 1, this must be 2 power 1, and B cannot have 2 anymore. So this is confirmed. It's confirmed already. Very happy. Now let's look at the LCM for 3. 3 squared. What does that tell me about? One of them must be a 3 square, isn't it? Can I have both of them being a 3 square? Why cannot? What happens if both of them have 3 square? Yeah, then the HCL will be 3 square. So only one of them can be a 3 square. The other must be a 3 power 1. Okay, so let's put a 2 over. Let's put a square over here. Now, do you agree that the 3's are all correct? Yeah, it's fully satisfied already. Okay, so let me tidy up my work. This is a 3 square. Okay, very happy with this. And now I move on to the 5's. The LCM says 5 squared. Where should I put it? Can I put square here and square here? Cannot, for the same reason, same many times. So it cannot be 5 square, otherwise the HCL will have a 5 square. Only one of them will have a square. The other will be power 1. Let's try this being power 2. Okay, let's give it to the first one. For you're very fast, Okay, let's just pretend that I'm slower, okay? This one, power 2, it's a power 1. It's satisfied, right? LCM 5 square. HCF 5. But there was one more condition. It says that both numbers are smaller than 100. What is my value of A now? 450. What is my value of B? 15. Right? 450 is more than 100. I cannot. Maybe we don't give the square to this guy. Let's give the square to B. Okay, let's try that. Over here. Now, this still satisfies the LCM and HCM. And what are the values? 75 as well as? No, this is 75. The one on top is 90. Okay, correct. And these are our two numbers A and B. Both smaller than 100, they have HCF of 15, LCM of 450. Was this fun? A little bit? Hey, support a bit, eh? It's alright, right? A little bit fun? A little bit, at least a little bit, because okay, what I hope, even if you may not admit it, it was a little bit fun because at least you have a little bit of motivation to learn because you are exercising your brain. But you feel like, wow, I don't understand. This is so difficult. I'm going to skip this question. When I see this question, I'm going to skip. I'm going to just copy it. That's not the right attitude. It's going to make your life very difficult for Sec 1, Sec 2, Sec 3, Sec 4. Whereas if you try and give yourself a chance to enjoy it at least a little bit, it will make your life easier. So looking at our faces, generally I can tell already who are the ones who are enjoying a bit and who are those who attitude must improve, otherwise you will suffer. Okay, now exercise 12. We have two numbers P and Q. Wow, look at the powers. P is 7 power X, I don't know what that is. Q is as a 5 power Y, as a 11 power Z. And then they tell us that the HCF of P and Q is 2450. State the value of X. Okay, so 2450, what do you think we should do with that big number? Break it down. We call it prime factorization. So 2450, let's divide this by 2, 1225. Can divide by 3, 4, 5. No, cannot divide by 3, so divide by 5. 2, 22, 4, 25, 5. Divide by 5 again. So 4, 9, and then 7, 7, 7, 1. So that is my HCF 2450. So A, no more A, P and Q. P, 2, 5 square, 7x. Q is my 2 power 3, 5 power Y, 7 power 3, and 11 power Z. My HCF ends up being 2 times 5 square times 7 square. Okay, keeping in mind, HCF means numbers that appeared in both P and Q. What then is my value of X? X is this. Think about it. What is the value of X? No calculation involved. 2. That's it. The value of X is 2. Because we are supposed to choose a smaller power. Since I ended up with 2, X must be 2. And then they carry on to say, oh, the LCM of P and Q is 343,000, which is, they break it down for you already. They're very nice to you. Okay, so P 2 times 5 square times 7 to the power of X was 2, right? And Q 2 to the power 3, 5 power Y, 7 power 3, 11 power Z. They tell us that the LCM is 2 power 3, 5 power 3, 7 power 3. So find the value of Z as well as Y. Y is a bit easier to find. Okay, so Z. What then is the value of Z? Z is over here. What is the value of Z? Such that it doesn't even appear in my LCM. I thought Mr. Wong say as long as it appears, it must be in the LCM already. Take the highest power and all the stuff, right? But now the LCM doesn't even have 11. Z is 0. What is 11 power 0? 1. Does that make sense? Yes, you're right. Z is 0. Very good. 11 power 0 is just 1. So technically, this number doesn't even appear. Okay? Power 0 is 1. So Z is 0. Now we need to find in part B the value of Y. Value of Y over here. What is the value of Y? Compare LCM. What is Y equal to? How much? 3? 3? Yes, it is 3. Very good. Okay, this is a similar question to what we did just now. So this is your homework, exercise number 13. Okay, there's a typo over here, the next one. Find the smallest positive integer value of m. Please change. This is m, for which 20m is a multiple of 75. And then you ignore this, you do by yourself. I didn't say whether it's correct, I didn't say whether it's wrong, okay? But just try this. And then the last one, 14. Exercise number 14. 63, they broke it down for you. Find the smallest positive integer n for which 63n is a multiple of 35. 63n is a multiple of 35. So let me do this with you now. I want you to spend a few seconds, think about it. Find the value of n for which 63n. What are we looking for over here? What is 63 times n? It is simply a multiple of 63 lah. Okay, so this number is a multiple of 63. Oh, wait, this number is also a multiple of 35. This same number is also a multiple of 35. What are we actually talking about then? Common multiple, and then you see the word smallest positive integer again. What are they looking for? LCM again. LCM of which two numbers? 63 and 35. So that gives us a clue. How do we do it? 63, divide this by 3, 21, 3, 7, 7, 1. And then our 35 will be our 5 and 7. So 63, 3 square times 7, 35 will be our 5 times 7. LCM, 3 square, 5 and 7. This is my LCM. They didn't ask for LCM, but I know that LCM is going to be required to solve it. Now the question is, hey, what is the value of n? Because this LCM is supposed to be equal to 63n. It is the same thing. Therefore, n equals to how much? N equals to, is it 3 square? This is equal to, okay, so equal to 63. Let me rewrite this for you. Instead of writing 63n, I can also write it as 63, right? 3 square times 7 times n. This is our 63n. Agree? 63n is my LCM. So let us compare. 3 square, same. 5. Supposed to be the same, but I don't see 5 over here. Where must it be? Inside here. And confirm has a 5. And then I've got a 7 and 7. So n equal to 5, just like that. Doable? Then we also have part B. Let me just finish it for you. Part B. Smallest positive integer of m, for which 63m is a multiple of 420. So this number is a multiple of 63 and 420. Okay, 63 we already broke it down. How about 420? 2, 210, 2105, 3, 35, 5 and 7, 7 and 1. So in part B, 63, 3 square and 7, 420, 2 square, 3, 5, 7. We are looking for LCM again. 2 square, 3 square, 5 and 7. This is our LCM, which is supposed to be equal to 63, which is our 3 square and 7 times m. So identify what is the value of m. It's just the last part already. And what is the difference? I've got my, in my LCM, I've got my 2 square. Does it appear in the 63? No, so it must be found in m. So I've got a 2 square over there. 3 square is already inside my 63. 5 is not inside 63, so it must be found inside m. We get 20. Okay? So the reason I want to go through this quickly is so that I can reduce your homework, which is over here. Okay, so now you have your textbook homework as well as these two. Exercise 13 and this example over here that is unnamed. Yeah, that's 2 questions from the notes as well as these inside your textbook. Okay, when is our next lesson? Tomorrow got lesson? Yeah, 1 period. Okay, bring this tomorrow, class 10.